All right, this is ITS128, and today is October 22nd. Let me share my screen. All right, here we are. And so we are in this class, and so it is, we are going to start, actually we're going to start chapter 6 today, functions, class number 18. So let's go to, let's start, I was checking it out here. All right, so functions are sort of the next step to um, to um, writing programs in ways where you can reduce redundancy in your code. If you have patches of code that appear more than once, if you have a section of code that appears more than once, you can group that code together, slap a name on it, and then further on in your code, if you ever want to execute that chunk of those statements again, you can just call it by its name, by that name you slapped on it, and then the statements that are associated with that name get executed. And you can also pass parameters, you can pass variables, and also these little programs can also pass back values also. So that's what we're going to learn today. And we've been actually doing this. Have we been doing? I think we've been doing this. I get my classes mixed up, but we've been writing code in the form of functions already, I believe. But anyway, now we're going to learn it formally and learn the ins and outs. So if you look at my screen here, user-defined basics. Okay, so the idea here is, let's say we have this main program here, and you notice the code here. Let me make this a little bigger. The idea here is that you're calculating three things, and the formula to calculate them is the same, except for there's one thing that changes, this f value. Okay, so you compute C1 using this formula, and you compute C2 using the same formula, and you compute C3 using the same formula. Now, in this little example here, you see that the C3 is not the same as C1 and C2, and that is supposed to be an example of an error that can occur when you're repeating your code a bunch of times, and you don't use copy paste. I mean, everybody would use copy paste, but if you don't, then you can end up with an error that looks like this. So let's run this thing. Oh, okay. So what we do then is we take the code, and we put it inside of a function. So this is like an example of that, where we have a name of the function, and we have the formula here, and this f. So the name of the function, you'll see what this means in a moment, but we pass in a value for f. It calculates, it does the same equation, gets a result, and then it returns that result. And the way it returns is you use the function on the right side of an assignment statement, and the function itself will take on the returned value. So let's run this thing. I'm going to run it twice. All right, so we have this main program, and we have these three examples or these three statements that execute. They're supposed to be the same, but you notice there's an error there. And so then what we do is we see a cluttered repeated code. Oops, there's an error in the third calculation. And so instead what we do is we write it this way, where we write that expression once, we put it inside, we name it, and we have this return statement. And what that is we are returning the value C, the computed value. And what that means is that wherever this appears in code further down, what actually happens is this thing gets executed every time it appears, and it actually takes on the value of C. So when this thing executes, when with this here, this thing here takes on the value of this when f is equal to f1. So let's go further here. Oh, this is the further example. Okay, anyways, I looked at this earlier. It's kind of hard to follow. Anyway, so consider the animation in the original main program, Fahrenheit to Celsius. That's the little program. It converts Fahrenheit to Celsius, and the formula is F minus 32. That quantity times the quantity 5/9. So in the original main program, how many times does this appear? Well, I guess it's 3 times. And in the last example, the main program is simplified. Okay, let's look at this. Okay, so we have a main program has got you have, first of all, you compute an A, which is this expression, and then you compute expression 2, this expression 2, and you add it to A, and that was what B equals. And then you compute a third expression, and you multiply that by B, and that's what C equals. Okay, so that's one set of code. And then you have a second set of code here where you have the same sort of structure thing where you compute A, and then you add A to the computed second expression, and then you add that A plus computed second expression times expression 3, and you get C. So it's the same structure here. And so the main program would be, we're calling XYZ this chunk of code. And why would A be? I don't really understand what they're trying to show us here. Let's just keep moving. Function example, printing the pizza area. Okay, so in this example, basically what we're doing is we're defining a function, and then we call the function, which executes it. So the way this works, and I think this is a pretty good example. Let's run this and see what it looks like. So first, yes. Let's try this again. Okay, so the idea here is that when this code executes, of course, it starts at the top and it executes down. All of this here, let me go back to this. How do I stop it? Okay. This here the way this code executes is all of this stuff, this part here, this top part. I'm gonna try something here. Hold on. I'm gonna open up my edge. And I'm gonna try to ZY books. See if this works. Is this edge? Shoot, what happened to my? Where's my? I'm wasting your time, I know. Six. I want to be able to write on the screen. It's not working. All right. What I was going to say is that as this code executes, because we're defining a function here, all of this code is just sort of stored. Okay, it's just sort of stored, and it doesn't execute. Okay, it's just sort of stored. It is remembered. Okay, the first statement that actually gets executed where it is this one, because this simply defines a function, but it doesn't execute anything until this is actually called. Okay, until this is actually executed as a statement. This executes it as a statement. It's only when this thing is encountered and executed as a statement, then all of this here is executed. And when it's done, it just drops down to afterwards. So if there were more statements down here, then once this executes, which really is all of this executing, once it's done, it just drops down and executes further. So I think that's what this is trying to show. So we see that the first thing that executes is this, and then it goes back up and it executes all this stuff up here until it prints this. And so then that's printed. And then when I hit this arrow key, it's going to drop down to below that, because that's what happens afterwards. So it returns the original function. So given the following program and the print pizza area function defined above, if we see this, we see that how many function calls to that exist? Well, 2, I think. And how many function definitions exist? Just one. There's just one definition of it. Just this thing up here, it's the definition. And how many output statements would execute in total? I guess what they're asking, assuming both of these execute, then yes, this output would execute twice, because it executes each time this is called. So I guess the answer is 2. And how many print statements exist in the program code? Well, just one, because this is the only one that exists, I think. All right. Okay, let's look at this one. So in this case, this thing, the code, code starts at the top and executes down. It hits this def statement, and then all of this is the body of the definition. And so that just kind of gets stored and remembered. And then the first statement that actually causes an execution, actually causes something to happen, would be this one. This just sort of stores it away, and this causes it to happen. Now, I can't remember if functions have to be defined before they're executed in this language. I don't think functions have to be defined, in line before they're executed. I think you could have this section here. I think you could have it down below, and when this thing comes along, it's smart enough to know that, well, it wasn't defined above, but it's defined below. So that depends on how they say how many passes the compiler takes to compile the program and get it ready to execute on the processor that it's executing on. And so if it takes at least 2 passes, first it goes through and it collects up all the definitions like this, and then it goes back up to the top again and actually executes the statements. And so when it gets to this, if this were actually down below, it would still work. I think it does. In fact, we could real quick test that. I'm gonna test that. Let me open up my notepad, and I'm gonna take this and copy it. Copy, and I'm gonna paste it in my Python one. Get rid of these. And let me shift tab. So it's like this. I'm not having much luck here. Okay, so if we execute this, let me execute this. CD desktop Python test.py. What am I doing wrong? It didn't work. Oh, I didn't save it. Gotta save it. Ignorance. Ignorant Halverson. Okay, there we go. So this executed first, then this thing executed, which prints out this silly face. And then this thing executes and it says, did it turn out okay? So what I'm going to test is if this definition has to occur before or after. I'm just going to see what this does. Be sure to save it. It did not work. It got to this and it's not defined. So in Python, I have determined in Python, functions need to be defined in the code before they are used. I can put it here, I think. So this should work. I'm defining it before it's used. So first it's going to print say cheese, and then it's going to collect up and define this function called print face, and then it's going to call print face, and then it's going to ask if it worked and see. So now if I run it, it should work, and it works. By the way, what we've basically done here is we could, of course, just not even have this, and then we don't have a, and then we don't have this. Okay, that's the same thing. That's actually what's happening. Works, see. But this chapter is about defining functions, so that's the original. Okay, anyway, good, got that, glad we got through that. Okay, so let's do this participation activity and see what I just showed you. Okay, so first goes down here. So the green one is the last line that was executed, and the red one is the next line to execute. So basically this was executed, and by executing this, it means collect up all of the indented code, underneath this statement, store it away, and whenever this function is called, it's going to execute this code. Not before, just it's got to be called first. It might not even be called, okay, in which case it never gets executed. Okay, so now this one's going to be executed, and it's going to print that. That's this out here, and then the next one is going to do this, and so it actually jumps up here and calls this thing, executes that, executes that, executes that, and you see the face being formed down here. And then it's going to jump back to right after. It's going to jump back to the print OK. See? So because it's done, the function's done. The function's done, which means this is done, and it jumps to there. All right, so here's a nice challenge activity. I've got some code here. Oh, okay. So here we have a print pattern prints 5 characters. It prints these 5 characters. Call when we call this function, it prints out 10 characters like this. So I guess what we're supposed to do is we're supposed to write code. Oh, we're just supposed to write code to call this print function, this print pattern function twice. The print pattern function prints 5 characters. See, that's what it does here. All it does, this function just prints 5 characters. Now we're supposed to call it twice to do 10 characters. Well, this is just a dumb, stupid one. So print pattern and print pattern. So I called it twice. Of course, it's correct. You do this. For I in range of 2, print pattern. How's that? Will this work? Well, it certainly should. Yeah, of course it works. All right. Except for they're expecting the first way. Doesn't matter. Okay, so print shape. There's a function called print shape. Oh, we're supposed to write it. Write a function called print shape to print the below shape, to print this shape. This is what the example output is. Okay, so we just have to write some code here that prints that out. So first we do def print shape. So I'm defining a function called print shape, and I'm just going to say print. And there's lots of ways we can do this. I'm going to do it this way because I like compact code. See if this works. Wow, it does work. Look at that. Of course, there's all kinds of ways that we could have done that, but this is one way. We can just have 3 print statements in a row, or we could have a loopy thing that does print this statement below 3 times. It's just all, we get the same output. All right, so now we can have parameters. And so this is an example of a parameter, okay? So we have this function where we're going to print the area of the pizza, where the input is the diameter. We input the diameter of the pizza, and it prints out the area. Okay, so now when we're out here, this is called an argument. We're going to execute print pizza area with an argument of 12. In this case, we're gonna call the print pizza area function with an argument of 16. Okay, now inside the print pizza area function, inside here, we call this a parameter. This is the parameter, and this is the argument. Same thing, except for if you're calling it, it's called an argument. If you're executing it, you get a parameter passed in. So how does this parameter, so this, and inside here, we're always going to call it pizza parameter. We can call it anything. We can call it D, we can call it PD, whatever we call it here. This is like defining a variable, and this is a variable, and we can use that variable here, and that's the only, we use it here. So the way this function works, of course, is first of all, we have a value for pi, because the area of a pizza is pi r squared. So and r is the radius, and you know that, right? Let's pop this up just so we know what we're talking about here. And where's my window thing? Oh. So we have a pizza here. We have a pizza, and a pizza looks like this. And the diameter is this line here, from here to here. That's the diameter, the whole thing. Half of it, this is the center, this is the radius, so the radius is half of D, and the area is pi r squared. So over here, we just define that to make it easy. First, we got to take the diameter and divide it by 2, and that's how we get the radius. And then we take the radius and we multiply it by the radius to make it the radius squared, and then we multiply that by pi, and so it's pi r squared, and that's the pizza area. And then here we print it all out, and we print out a pizza diameter inch pizza. So this is the diameter. When you say it's 12-inch pizza, you're talking about the diameter. A 12-inch pizza is this is the area. So this is the computed thing, and this is the thing that's passed in. This is the parameter. So let's see how this actually executes when we execute it. And remember that the red arrow means it's the next line to execute, and the green arrow means it's the line that was just executed. So the first line that's going to be executed, well, let's just do it. So this definition, of course, says we're defining a function, collect all the statements together, store them away someplace, and then this thing, when this thing executes, we go back and we start executing the function here. See, execute the function, boom, we print out something, I suppose, to show what's printed. Okay, and then once it prints it out, it drops, then the function's done. So then it's going to drop down to the next line after the function that was called. So it's going to drop down to 9. Boom. And now it's going to call the same function again, except for this time, pizza diameter is going to be 16. So we go dun, 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 print that thing out. Boom. And now it's going to drop out to nothing because we're done. Download. So that's how that works. Complete the function definition to have a parameter. Complete the function definition to have a parameter named, oh, user age. Okay, well, put user age here. Parameter, yes, parameter. Parameter is inside the function, argument is, okay, so this should be right. Call a function named print age, passing the value 21 as an argument. Call a function print age, calling, so it'd be print age, parentheses, and the argument is 21. Is the following a valid function definition? Beginning? No, I don't think it is. I don't think you can have an expression as a parameter. You can have an expression as an argument. So, this is a variable. This is a value, and this is the name of a variable. So, this is the name of a variable that takes on this value. So because this is a value, this can be an expression, because an expression evaluates to a value. So you can have, 12 plus 4 plus times whatever variables and everything, as long as if it's a big long expression, as long as when it comes time to call the function, that expression is evaluated and it turns into a number that this thing takes on. So that's how that works. And then, so I think the answer is no. Now watch me be wrong. Yes. Assume a function called printNum is defined with user_num as a parameter, and this thing simply prints the value of user_num without any space or new line. What will the following code output? Okay, so well, I guess it's 4321, because it's just going to print the thing without any white space and no new line. So it's just going to print this thing out, and just that's it. So let's see if this works. 4321. Oh, that's nice. Yes. Okay, we can have multiple parameters. Here we got we're passing in 2 parameters. And so here we're passing in 2 arguments. So this first time is, we're going to figure out the pizza volume. So I think the pizza volume, where you figure out the area and you multiply it by the depth or the height of the pizza. A deep dish pizza would have more volume than a thin crust pizza, I guess. So we see we got the pi, we got to figure out the radius, we figure out the area, and then the volume is the area times the height, and that's this thing. And then we print it out. It's like that. And so we're doing it 3 times, and so it prints out like that. All right. Which correctly defines 2 parameters, x and y, for a function? Oh, it's you got to put a comma. See, comma there, comma. No, right there. So it's this answer. It's not this one. It's not this one. Of course. Which correctly passes 2 integer arguments for the function call? Well, it's the same thing. You got a comma. You have to have a comma between them. And this is going to evaluate to 49. This is 99. So we're passing a 99 and a 49. Given the function definition of this, b is assigned what value during this function call? Well, it's A, B, C, and this is A, B, C. Well, I guess it'd be 55. Given a function called this, and given these as valid arguments, which are valid, which one, given these variables, which one of these are valid arguments? No, with given variables I, j, and k, which are valid arguments to the call? Well, there's three. You got to pass in three of them, and you got to separate it by a comma. So does this pass in three of them? No. Does this pass in three of them? It does. K, and whatever k is, whatever I plus j is, and whatever 99 is 99. And this one is just going to be one. This is just one argument. This is three arguments. This is two arguments. Well, we need three arguments because the function is defined as looking for three parameters coming in. What will be printed for the following function call? So we've got num1 is 1 because of this, and num2 is 2 because of this. And so we're going to print num1 plus num2 is whatever that is. By the way, this is the function. Now it's not quite the same analogy because we have we can have a variable number of arguments for the print function. It's a smart enough function to recognize that it just collects the arguments as they come in and evaluates them and prints them. So what would be printed here? It'd be what will be printed? Well, I guess it would be 1 space plus space 2 space is space whatever that is, which is 3, I guess. 3. Enter. Well, okay. Write a function using this to print the sum of x and 400. Write a function call using print sum, this one, to sum x and 400. I don't know, is it print sum x comma 400? Providing the arguments are in order. All right. So what happens if I put 400? No, I'm not. Okay, so here's a challenge activity. The example here is we have a function named print age, and all it does is it prints out whatever. I mean, we have a function called print age, and a parameter called user age, and all this does is print out user age like this. Okay, and so here we define a variable called age to print, and it's going to be the value is going to be 21, and then we pass this variable, which equals 21, as an argument into print age. Okay, so so I'm going to pop this up, and it's 4 o'clock here. Yeah, let me clear this. So I have a variable called age to print. So first of all, I've got a definition of print age. No, I'm going to do it this way. I've got an age to print variable. And I've got a I've got a user age variable. Well, this isn't very interesting, but age to print takes on the value 21, and then when this thing is called, age user age goes into here. That's going to equal 21, and then it's going to print out this. Okay, so let's start this and see how it's going to make this more difficult. Okay, here I've got print age is 18, and so 18, age to print gets assigned 18. Print age is called with age to print as an argument. It's 18. So this thing starts to execute. It's 18. And so what's going to print out is I am whatever this is, which is this. So I am 18. I am 18. Okay. Nice. This one, here we define a variable called product price, and it's set equal to 24. And then we have another variable called tax amount, and that's set equal to 4. So this parameter here, this argument is going to be, this is an expression which is going to evaluate to a single value, and that's the argument that's going to go into there. So this is 24, this is 4, add them together and you get 28. And then this thing is called here, and this is 28. And so it's going to say price colon $28. Price colon space $28. Enter. And this one is I'm just going to talk you through it, but I'm not going to do it, and that way you can do it. But I'll talk through these. Okay, we've got this definition. Print operation is defined. It's expecting 2 parameters. All right, great, 2 parameters. So first thing that's executed is this even number. It sets the variable even number equal to the value 6. It sets the variable odd number equal to the value 5. It calls print operation, and the first parameter is even number, which is 6. The second parameter is odd number, which is 5. So when this is called, we're up here. This one is going to be 6 because it's the first one, and this one's going to be 5 because it's the second one. So we print 6 prints here, 5 prints here, and whatever this is, whatever this computes to, let's see, 6 minus 5 is 1. That gets printed here. That gets displayed here. So the answer is going to be, number 1, it's going to be this. It's going to be 6 space. It's going to be 6 because of this. And then a space, and then a hyphen, and then a space, and then this one, which is 5, a space, an equal sign, a space, and then whatever this is, which is this expression after it is computed, which is 6 minus 5, is going to be 1. So then a 1 is printed here. So it's gonna print, 6 space hyphen space 5 space equal space 1. I got to put an answer down there. Look at the next one. Well, why don't you work on the next one? If you have any problems, let me know. Okay, here, let's do some challenge activities. Complete the function definition to output the hours given minutes. Oh, takes minutes, displays hours. Okay. Hours given minutes. So we're supposed to put a function here. How about I'll put so it takes original minutes and it's supposed to output the hours. So I guess if you got the minutes divided by 60, you get the hours. So print, well, I can say hours equals orig minutes divided by 60. And then I want to print hours. Yeah. I wonder if this is going to work. It should work. I'm using there's going to be a floating point number. A floating point number divided by an integer. It should still work. Let's see if it's right. Yes, it's right. Okay, great. All right, let's do this challenge activity. So define a function, print total inches with parameters number feet and number inches. That prints a total number of inches. Notice that there are 12 inches in a foot. So sample output is inputs 5 space 8. 5 comma 8. Okay. Anyway, so this is feet and this is inches, I guess. So 5 times 12 gives number of inches, which is 60. And we add the remaining inches and we get 68. So I have to write a function here. So I'm going to write it as whatever, def print total inches. And I have to pass in, I'm passing in 2 arguments here, so I got to name them. I'm going to call it F and I. How's that? Call them anything I want. And it is going to be just inches equals feet times 12, and that gives me inches. And then I'm going to add the remaining inches. And then I can print just inches. So it's going to look something like that. Is that right? Oh, I have to print this out too. You can do that. All right. What's next? Section 6.3. I wonder how far we can get here. Okay, so now we can pass, once it's done computing, we can pass back a value, and that will be, that value will be, will replace the named call. And so now what this means is our functions are not just going to be sitting out there, you know, by themselves. Here, you know, this function is just sitting there all by itself. This function is just sitting there all by itself. Okay, so you call the function, it's going to do something, and go to the next line, call the function, it's going to do something. Whereas if we may want, see here, we just call it and it does something, and what it does is it prints. But here we're actually going to return a value. So the way we do that is we have a return statement. Here we have a return statement, and if we have a return statement in the function, then the function is probably not going to be used. Is probably not going to be used where it's just sitting there all by itself. It's probably going to be used in an expression because the name is going to be replaced by a value that is returned. And so if it's going to be in an expression, then you're going to see it on the right side of an equal sign, because a computer programming statement is a variable equals and then an expression on the right side of an equal sign. So this here defines the function, and then we have a variable here that calls the function. And you notice it's on the right side of an equal sign. The right side, this is called an assignment statement. It's on the right side of the assignment statement. And we're calling it with an argument of 7. Okay, so let's go back and look at this function definition. Same, we have a def saying we're defining a function. We have a name. We have a parameter, and we're going to call it num_2 number underscore square. And then we're going to return this computed value here. So compute that value, and then we're going to return it. And because we have a return here, then this thing takes on that return value. So when this thing executes, it's going to be replaced. This thing is going to be replaced with whatever the value is returned here. So if we look at this thing execute, first thing, let's start over again. And let me undo that. Okay, so this thing executes. 7 goes here, and then that gets executed. 7 times 7 equals 49, and so we're going to return 49. So that means this here is going to be replaced by the value 49. And so now num squared is 49. See, 49 gets put in there, and then it prints out 7 squared is 49. Add a return statement to the function that returns the result of adding num2. So here we're supposed to just put the expression for the value that should be returned when the parameters coming in are num1 and num2. And what we should return is the sum of num1 and num2, or in other words, adding num1 plus num2. So we're simply num1 plus num2. That's all. Add a return statement to the function that returns the cube of the argument this. Oh, returns that. Well, that's just this, dude. You have to put the word return in there, and then you just it's that. That's all it is. Calling functions in expressions. Okay, it's the same thing. I mean, here we're just showing that we're going to put. Oh, this is just. All right, we have this function called square root, and it's going to return this. Now, why would we do this? I don't know. We're just doing it. Here we have a function called print value, and all it's going to do is it takes this argument, takes this parameter, and it prints it out. So y equals square, determine which statements are valid. Okay, well this is the word square root, and it takes on with a parameter of x, the word square root with an argument of 49, and it sets that it sets y equal to the returned value. Well, yeah, this should work. This should not work because here we're saying, whatever this computes to, this is going to compute to this is an expression. This is going to compute to something, and the z is over here. this is gonna be, the square root of 49 is 7. So what this is saying is 7 equals z. Okay, that if if we want 7 to equal z, we really want z to equal 7, and so 7, the z's got to be on the left and the 7's got to be on the right. This puts the 7 on the left and the z on the right, which doesn't make any sense. So it's false. Okay, this is fine. We have this thing is gonna evaluate to something. 12, because the square root of 144 is 12. So this is going to evaluate to 12, and we're adding 1 to it. We're 1 plus 12, that's 13. And so what this statement does is this assigns y, it assigns y the value 13. It assigns 13 to the value 1. It assigns y to the value 13. So there's nothing wrong with this. This is a perfectly fine statement. This is a perfectly fine statement. Interesting, huh? So because this thing evaluates to something, that evaluates to 4, because the square root of 16 is 4. Well, now we've got 4, so this is a 4. So this thing is going to be the square root of 4, which is 2. So this statement here assigns y to the value 2. We're nesting these functions. That's one of the neat things about math. It's this concept called closure, and which just means you can put functions inside of each other. You can nest them down as deeply as you want, and it's okay. It just what this is going to do is first it's going to evaluate this, and then it evaluates to a particular number, and then that number is a perfectly acceptable argument for this function. It just happens that these two functions are the same. Anyway, so this is true. This won't work because because you have to pass it an argument. You have to pass it an argument. And here you're not passing anything. Yeah, so it's expecting something. This isn't going to do anything. It's just it evaluates to 3 and just sitting out there nowhere. It's not this returns something. So since this function returns something, you have to see it where you would see an expression. An expression is on the right side of an assignment statement. This is not an assignment statement. So this should be false. I hope it is. Oh yeah, you're right. Okay, it is. Okay, it's a useless statement, but I guess it is correct. You can do that. Do I have an example up here? Well, now there, in other languages, if this were another language, some other languages, they aren't going to flag this as having a problem. It may evaluate to something. It may do more than one thing. It may print some stuff out and also evaluate to something and return that as a value. And so what this does is it computes 3. It's possible that this function actually does some other stuff too, like print out some stuff. In this example, it doesn't. All it does is return something. But so then when this thing executes, it returns a value, but the value doesn't go anywhere. It just disappears, and that's perfectly fine. So if this is technically it's a correct statement. It's a legal statement, but it doesn't do anything. And so if you see something like this in your code, you probably have an error, but the Python, system is not going to tell you anything. It's not going to say that it's an error. It's not going to think anything or do anything. Now, let's see. I don't know if this is going to be. We'll see what the answer is to this, but really this doesn't return anything. So let's see. Is it true? Oh, it evaluates to the word none. Ah, interesting. That's interesting. I'm gonna copy this. Copy, and I'm gonna put it over here. And I'm gonna say, how about this? Print, this is gonna be tricky. Print val of ABC. Okay, so this is going to print something that, this is going to call this function, and this function is going to take its ABC is the argument. It's going to take ABC as the parameter. It's going to print ABC, and then it's going to return. It's not going to return any value. So then, according to Python, there's the default for nothing is none. Is that right? Default for nothing is none. And so this should first print ABC, and then a new line, and then should print none. So the none prints because of this. The ABC prints because of this. Let's see what this does. Save. Yeah, look at that. ABC and none. How about if I do this? Print val, print val. Let's see what that does. It should be ABC none none. I think. Yep. All right. Interesting. Ooh. This is gonna take the word none and try to add it to one. I wonder what this. Let's see what it does. Take this, copy, and I'm just gonna put that here. I think I'm going to get an error because none is a string and one is an integer. Yes, unsupported operand type for a plus, an integer and none type. So yeah, that should be an error. Is that how you convert it to a string? Just see what this does. Can only concatenate a string. Oh, this is not even a type. So this is not even a string. This is a nothing. It's a none type. You can't convert a none type to a string. Oh, can I do this? I'm wasting time, aren't I? Yeah, so this takes the string. This is going to return. Well, first of all, it's going to print the 9, and then it's going to return the word none. But it's not a string. It's a none type. But I'm going to make it a string, which now I can treat it as a string NONE. And then wait a second. How does this? And then the plus concatenates a plus string plus a string concatenates the two, and this is going to be a 1 and concatenates it with the word none, and we get one none. All right, that's interesting. This should be true. All right, it's let me just try to zip through this, and we will have gotten through 3. Okay, I'll speed it up next time. But let's go through this. I don't want to skip stuff. I'm finding if I skip stuff, then it's like puts too much burden on you guys to figure it out. Program of the function to convert height in feet and inches to centimeters. Okay, so here we define a centimeters per inch. We define inches per foot, and then we define a function with named. This is the name of the function, so when we use it, we name it, and then it's got 2 parameters. And this thing takes the first parameter, multiplies it by this inches per foot value. So it takes feet times 12, which is going to give us inches, and it's going to add the inches. Okay, and once we get all the total inches, we're going to convert this total inches to centimeters by going centimeters per inch. So it's going to end up being cm, and then we're going to return that. So what this will be replaced, this thing will be replaced with whatever this computes to, which is what is returned here. I've told people, oh, my class is done at 4:30, no problem. It's 4:28, and my wife just tries to call, and this other guy tries to call me. So it's like, what? I let my class out early? No, I don't. Sometimes I do. Okay, so we start out with a parameter here and inches here, and we call the function with these 2. So this is going to be 6, and this is going to be 4, and it's computed by this here, computes it, returns the value, and that gets stuck into there, and then we print it out. So let's see what this looks like real quick. So that gets executed. This gets executed. The definition of the function gets defined, stored away. This thing executes. This thing executes. Okay, now at this point, inches has a value, feet has a value, the function's been defined, and these 2 constants have values. And so now everything is defined, and we can go down and we can execute this thing. And this thing is going to call this function. So we're going to see it jump up here and execute this stuff. Okay, so call it, what goes back up here, executes this. This is just a comment, of course, so it's no executing. This thing executes. This thing executes. It has a value now. This thing has a value, and it's going to be returned. And so why is it there? Anyway, so once this returns, it ends up going to the next line, because this line gets executed, which calls this, and then centimeters has a value. It has a value whatever this is, and then it prints it out. So that gets printed out. This has a value. This has a value. This height to US, the definition here is a jump out to this other function which gets executed, and the value gets returned. This thing it returns with a value, so there's this value in there, but this thing doesn't get executed until this is kind of misleading. Anyway, so it's 431. Okay, these are hierarchical calls. See here. Okay, so let's just quickly do this one, and then we'll save hierarchical calls for next time. See, hierarchical calls is you have a function which calls a function. See this pizza calories calls pizza calories, which and before I can figure out the calories, you got to figure out the size of the pizza, and that's this thing here. But if we just fix this, complete the program by writing and calling a function. Writing and calling a function that converts a temperature from Celsius into Fahrenheit, and this is the formula. So the Celsius to Fahrenheit. Let's copy this here. Copy, and it probably is going to be pasted right here a bit. It's going to be enter a number in Celsius, and that's going to go in here. Enter a number in okay, call the conversion function, and it should be something like Celsius to Fahrenheit. So the parameter should be C, because that's what this is. This is going to be multiply, not X. 9 divided by 32. F we're going to return F. So now this thing has the value F. I don't know what that is. Call a conversion function. Okay. Temp F equals C to F, and it's going to be temp C. See, so see that's this is the argument. I'm going to read it in the argument. Call this function, gets that, and here we just print that. Okay, and we're going to start with 50. Run it, see if it works. Yeah, great. This is misleading because really we're entering a number there and prints that. So I don't know if that's right. Let's see. 40, 30, 40. Yeah, that's probably right. Pretty close. All right. Okay. So I'm gonna end it there. Does anybody have any questions? Feel free to email me, or I think I hope I'm caught up with your questions. If you've been emailing me, if you have any other questions, just let me know. And if it's a good question, I will solve it in class. Otherwise, I'll solve it, help you with it one-on-one. So I will see you next Tuesday. Have a good weekend. All right.
Thank you.
You're welcome.